All right, today we're jumping into what is honestly one of the greatest detective stories in all of human history. It's the story of how we discovered an entire invisible world. For basically all of time, the things that were killing us most were microscopic. We couldn't see them. We didn't know they existed. This is how a few brilliant and sometimes just plain lucky people finally pulled back the curtain.
So just think about this for a second. How do you fight an enemy you can't see? An enemy you don't even know is there? For thousands of years, that was humanity's reality. When plagues hit, we blamed everything from bad air to angry gods. So how did we make the leap from that to germs? Well, it was a revolution. And it didn't start with a cure. It started with a shield.
Our first major win in this fight came way before we had any clue what was actually making people sick. It was a victory of pure observation, and it was aimed at one of the most feared diseases ever, smallpox.
And you know, what's really interesting is that the core idea wasn't brand new. For centuries, people in places like China and India had this practice called variolation. Basically, they'd expose a healthy person to a tiny bit of smallpox to try and build up immunity. Super risky stuff. The real breakthrough came from a simple observation out in the English countryside. Milkmaids who caught a mild disease called cowpox just never seemed to get smallpox.
And that's our cue for a doctor named Edward Jenner to enter the story. He hears this folk wisdom, and he decides to run an experiment that was, well, incredibly brave and, let's be honest, would be totally terrifying today. In 1796, he took pus from a cowpox blister on a milkmaid's hand and scratched it into the arm of an 8-year-old boy. The boy got a little sick, but then he got better. And here comes the moment of truth. Jenner then exposed the boy to smallpox, and nothing happened. The kid was totally immune. Jenner had found the shield.
And just like that, with that one incredibly risky experiment, the entire concept of vaccination was born. It would literally change the world. The name itself, though, that came later from Louis Pasteur, who called it vaccination, from vacca, the Latin word for cow, as a nod to Jenner's amazing discovery. So, okay, we had our first shield, but we still had no idea what we were shielding ourselves from. For that, we need to meet our next great investigator.
If this whole thing is a detective story, then Louis Pasteur is the master sleuth, who finally put a face to the invisible killer. He didn't just find one bad guy. He proved that a whole microscopic world was operating all around us, influencing everything.
I mean, this guy was a machine. He proved that these tiny organisms, these microbes, were the reason wine and milk were spoiling, which led him to invent pasteurization. And this is a huge one. He completely demolished the age-old idea of spontaneous generation by proving that life doesn't just pop out of nowhere. Microbes have to come from other microbes.
And this quote from him just absolutely nails it. He showed everyone that these tiny, invisible things were actually huge, powerful forces that were shaping our world in every way imaginable.
And like so many great scientific leaps, Pasteur's next massive discovery came from a mistake, a complete accident. His team was studying chicken cholera. They were about to inject some chickens, but they accidentally grabbed an old bacterial culture that had been sitting around for a while. The chickens got a little sick, but they didn't die. But here's the amazing part. When they later injected those same chickens with a fresh, deadly batch, the chickens were completely fine. Pasteur put 2 and 2 together. He figured out that the old culture had become weakened, or attenuated. It was just strong enough to give the chickens' immune systems a training session, but too weak to actually kill them. This was huge. He hadn't just found a vaccine like Jenner. He'd figured out the principle for how to make them, on purpose, in a lab.
Okay, so Pasteur proved that germs cause disease. Awesome. But which germ causes which disease? You couldn't just guess. You needed a system, a set of rules to prove it beyond a shadow of a doubt. And the guy who wrote that rule book was a super meticulous German doctor named Robert Koch.
Think of Koch as the ultimate forensic investigator of the microbial world. He wasn't satisfied with, it's probably this one. He wanted ironclad proof. His whole mission was to draw a straight, undeniable line from one specific microbe to one specific disease. And he was incredibly successful, identifying the culprits behind huge killers like anthrax, tuberculosis, and cholera.
And to do this, he laid down the law. He created this brilliant 4-step checklist that we now call Koch's postulates. It's so good, it's basically still the gold standard today. First, you have to find the microbial suspect in every single sick patient, and not in healthy ones. Second, you've got to isolate that microbe and grow it all by itself, in a pure culture. Third, you take that pure culture, introduce it to a new healthy host, and they have to get the exact same disease. And fourth,
The final nail on the coffin, you have to pull the exact same microbe back out of that second host. You do all four, case closed. You've got your culprit.
So now we had it all, right? We knew who the enemy was, and we had a set of rules to prove they were guilty. And that's when the floodgates just burst open. The germ theory wasn't just a cool idea in a lab anymore. It was a practical blueprint for building a whole new world of medicine.
Just look at surgery. Before this, hospitals were, frankly, terrifying. A surgeon's coat, stiff and caked with blood from past operations, was seen as a badge of honor. Can you imagine? Infection after surgery was so common that doctors just thought it was a normal part of healing. But then, Joseph Lister read Pasteur's work, had a massive light bulb moment, and started using carbolic acid as an antiseptic to clean everything. And bam! All of a sudden, survival rates just skyrocketed.
And the innovations just kept on coming, one after the other. Our whole toolkit for microbiology started to fill up. One of Koch's assistants, Richard Petrie, invented the Petri dish, so simple yet so brilliant for growing bacteria. Hans Christian Graham developed a special staining technique to tell different bacteria apart. And then you had the visionary Paul Ehrlich, who started dreaming of a magic bullet, some kind of chemical that could hunt down and kill a specific germ without hurting the patient. He basically laid the groundwork for chemotherapy.
But the biggest weapon of all, the real game changer, arrived, you guessed it, thanks to another bit of luck and a messy lab. It's 1928. A scientist named Alexander Fleming gets back from vacation and finds one of his petri dishes has been contaminated with mold. But he notices something weird. Right around that blob of mold, there was a clear circle where all the bacteria were dead. The mold was killing the bacteria.
That mold was a species of penicillium. Now, it wasn't an instant miracle. It took another decade and the hard work of two other scientists, Howard Florey and Ernst Chain, to figure out how to purify it and turn it into a usable drug. That drug was penicillin. In 1945, the three of them shared the Nobel ties. The age of antibiotics had officially begun, and medicine was never, ever going to be the same.
So from Jenner's shield to Pasteur's theory to Fleming's magic bullet, this incredible, century-long detective story gave us the tools of modern medicine. We unmasked the invisible enemy. We learned how to fight it. But the story isn't over, not even close. These microbes have been on Earth for billions of years. They are masters of survival. Which leaves us with a really critical question for our time. What happens when the enemy learns our playbook and starts to fight back?